limits, or section 3.1. So really you have to understand how functions can be represented. So functions can be represented as a graph, which is represented right here. It can also be represented as a table, which isn't used too widely, but I'll show how you can figure out a limit using a table. And then also just general function, asking what the limit is with a given function, and I also put a piecewise function on here. So I'm going to go through this video and have 3 different parts. If you want to fast forward and look at specific places, then that's perfectly fine. This might be a lengthy video. So what we have here is, I want to be clear in this. If it's saying the limit as x approaches 1 with this particular video, understand that the approaching from the left and approaching from the right are what make up this limit as x approaches 1. So think of these as pieces of making this decision. So when it has the 1 plus, that means coming from the right. So if I'm looking at x values as I'm approaching, from the right, which would be from this area. So let's see, 3, 2, 1, and then maybe 1.1, 1.01, and as we get closer and closer and closer to x equaling 1, what y value do we get close to? Well, as we get closer and closer, again, the key word here is approaching, we get closer to 2, all right? Now, if we go from the left, again, we're coming from this direction. We're plugging in x values. It could be 0.9999, 0.99999, and we get closer and closer and closer. It looks to the value of 2. So understand that making the decision as the limit of x approaches 1 in a graph, we kind of break it down to this. Well, what's it approaching from the right? What's it approaching from the left? If these two are the same, then that is the limit, okay? So really in really regular context, you'll never have, for this practice, we're saying from the right and the left, but for the majority of time, when somebody asks for a limit of a graph, they'll just give you as x approaches 1. Okay, so let's talk about a problem here. So we'll notice that, okay, so before I make the assumption as the limit approaches, as x approaches 3, I'm going to come from the right and the left. So if we look at this, if I'm approaching 3 from the right, so I'm moving in. Again, the reason why I'm going from here is I'm looking at y values as I get closer and closer to 3 as an x value. So as I get closer, let's say 3.1, 3.01, 3.0001, we're getting closer and closer to the y value of 2. All right? So as I'm coming closer from this direction, I get closer to 2. If I'm approaching from the left, you'll notice that as I get closer, 2.99, 2.99999, 2.9999, I'm getting closer to 4. So when I look at coming from the right and coming from the left, because they are different, therefore the limit does not exist. So if I'm being clear here, I'm saying that these are the building blocks of making the assumption of the limit. And so if they are the same, then that is the limit. If they are different, then the function does not exist. The lit does not exist. And you'll notice that when it has a break like this, and we talked about it in class where it's discontinuous, like in this way, then it is going to be does not exist. All right, so that's the graph section that we talked about. We've talked about a lot this week. Here is the part where we look at the table. Now, a few people use this as a way of finding the limit, but it certainly can be done. So essentially what you do is it's saying as the limit as x approaches 2. So what I'm going to do is I'm going to approach, this would be these numbers right here. If you look at it from this context, is the limit as x approaches 2 from the left. And then these numbers are the limit as x approaches 2 from the right. All right? So you'll notice how they're getting closer and closer to 2. These are getting closer and closer to 2 from the left side. And so I sped up time just a little bit I already plugged these into my calculator. So if I plug 1.9 into this function, I would get 9.41. If I plug in 0.999, I get 9.9401. If I plug in 1.9999, I get 9.994. And so some of you can see that as I'm approaching 2, I'm getting closer to some number here. Okay, so this is just the left side. And then let's say I come from the right side. So we got 10.61. If I come from this side, I get 10.06. As I come from 2.001, I get 10.006. All right, so you'll notice that as I'm coming from this direction Let me draw some arrows. As I'm coming from the right, as I'm coming from the left, what are we starting to approach? What number specifically are we approaching? Okay, and you would say, well, that's 10, right? And you're exactly right. So the limit as x approaches 2 in this particular function is 10. And I got that found out by just plugging in numbers closer and closer to the value I'm trying to find, or plugging in. And you'll notice I can't plug in 2 because if I plug in 2, it's going to be a hole. And so in this case, because it is coming to the same point. But you'll notice that I can't plug in 2 because it's undefined at 2. All right. So there's another table. That one, again, we didn't spend too much time on because it is a little bit time consuming, but again, another strategy that you can use, and maybe that hopefully helps to explain the graph a little bit more too, that as I plug in x values closer and closer to the limit I'm approaching, I can find out what the limit is, okay? So now let's talk about if I was just given a function. Now the first thing I want to do, I talked about this in class, is first step would be 1. Let's see. 1 would be, can I plug the number in? I'm just going to talk about it. So first thing I look for is, can I plug the number in? Well, in this case, if I plug in 5, it doesn't work because it's undefined at 5. So my next step I'm going to do is I'm going to try to simplify, because ultimately I want the function to work. I want to find the limit. All right, so what I'm going to do is use my algebra toolbox, and I can see, well, let me see, maybe I can factor this. So if I factor it, I get 2 factors of -10 that would equal -3. In this case, that would be x minus 5. Ooh, that's a bad 5. X minus 5, x plus 2 over x minus 5. So notice I haven't changed the function at all. I've just rewritten the top in a factored format. And then what you'll notice is now I can cancel out those, and I'm left with, well, what's the limit as x approaches 5 with this simplified expression? Can I plug in 5 now without breaking rules? And the answer is yes. So if I plugged 5 into this, my simplified expression, I would get just simply 7, which is the limit as x approaches 5 in this particular function. So it's our goal for these to work, and we have to use all of our algebra possibility, or our techniques or tools that we have to make it work. And then, sometimes it's just impossible for it to work. All right. Now this one is one that we haven't learned too much in algebra as far as tools in your toolbox, but we'll notice that I can't plug in 36, so I have to try everything possible to try to make it work. So in this particular case, I'm going to use something a little bit different. What we're going to do is we're going to multiply the square root of x plus 6, and it's important that it's the opposite, okay? Now, I could do this, and maybe it's still not going to work, and which I would say does not exist, but I'm going to try this particular technique. So you'll remember that if I take the square root of x plus 6 over the square root of x plus 6, this would equal 1, which doesn't change the value of this function at all, because 1 is a multiplicative identity, meaning if I multiply anything times 1, it still stays the same. So I'm not breaking any rules here. So the key here is I'm going to FOIL this. All right, so we got the square root of x times square root of x. That would equal x. Square root of x times 6 is 6 square root x, minus 6 times the square root of x. And then -6 times 6 is -36. All right, now if I simplify this, you'll notice these cross out, and I'm left with x minus 36 on top. Now, what we have here is I didn't want to FOIL this. So if you were to FOIL this, you're going to kind of lose your process on the bottom. So I'm going to keep that as, because my goal is to simplify that. So let's see, square root of x plus 6. All right, so you'll notice now when I did that, I crossed those out. Again, I'm still trying to find the limit as x approaches 36. And I'm left with 1 over the square root of x plus 6. So the limit as x approaches 36. Now I don't have a problem. I can plug in 36, which would be 1 over square root of 36 plus 6, which would equal 1 over 6 plus 6, which again would equal 1 over 12. All right? So my limit as x approaches 36 is 1 over 12. And again, this is a technique that we haven't used too much in algebra, but it's a technique that you can use to make the limit work. All right? So my last but not least, I have a piecewise function. So let's figure out how we're going to make this work. So again, going back to our table is really going to help. So if I look at, see the limit as x approaches 3. So we'll notice that it has a breaking point here. So as I get closer and closer to, let's say, 2.99, you're going to get closer and closer to some value here that we hopefully can see here. So as I get closer, let's say if I just plug in 3. I know it says this is less than 3, but do you see how if I plug in 3, I would get 2, right? So it would be 2. So if I plugged in 2.9999, I would get, as I get closer and closer to 3, you'll notice I'll get 1.9999, okay? So I would say, and then of course when you plug in 3, you get 2. So the limit as x approaches 3 would just simply be 2, all right? Because if I plug in numbers closer and closer to 3 in this top function, I get 2, and the number as I get, obviously when I plug in 3, I get 2. So that works out just fine. Let's talk about 5 though, okay? So if I plug in 5, in this case, I get 2, which is what that would equal. So if I approach from the left, I get 2 as an output. So let's see, the limit as x approaches 5 from the left, I get 2. The limit as x approaches 5 from the right, if we look at this way, like let's say 5.00000001 would be 8.000001. So no matter, as I get closer and closer to 5 from the right, I would get 8. So you see how these don't match up, meaning because that's what the limit of x approaches 5 is based on. Therefore, it does not exist. All right. So hopefully this video, I know it's a little lengthy video, but hopefully you're able to navigate your way through it and try out the problems. And so we'll be looking at 3.2 coming up here today. All right. Bye-bye.